This is the Unit 1, the Alphabet and Grammar of Geometry, Preview Video 1.4, Brain and Hand Problem Solving. Take a moment and close your eyes. With your eyes closed, deep inhale. Hold your breath. Slowly exhale. Open your eyes. Taking a look here, you want a location, a date, time that you are watching this video, as well as a parental sign-off affirming that you did this watching the video versus copying. Students, the background for this video comes from the fact that I am a digital immigrant and my students are digital natives. Several years ago, I would be tutoring students doing relatively simplistic problems. And I was getting increasingly students who would look at it and tell me that they don't get it. I don't know. And I started observing that their hands were usually folded or they were simply staring at the diagram. And I would start taking students' hands and physically tracing over the diagrams. And all of a sudden I would get this reaction in tutoring. Oh, this is an easy problem. And I was seeing this over and over and over again. And I ended up doing my master's thesis asking the question, how is digital technology changing the way that brain processing is working? The next 5 thoughts are key synthesis from that master's thesis. First thing you need to understand is that your fingertips literally are connected to your frontal cortex. Your frontal cortex is the thinking part of your brain, the conscious thinking, problem-solving part of your brain. Your brain does not simply get information through your eyeballs. That's my attempt at an eyeball. Sorry, art students. Your brain gets information through physically interacting with your environment, with your hands and gesturing. 2, technology usage is reshaping our brains. Because we are keyboarding more than we physically write, we're clicking on stuff more than we're physically drawing and coloring most of the time. We're tapping on screens more than we physically handle 3D model. All of that lack of physical interaction with our environment is changing the way our brain processes information. 3. Hopefully you understand this. If not, this is really revolutionary. Screen reading is different than print reading. Our eyeballs, when our eyes hit a printed page, a magazine, a book, we tend to go systematically in our culture left to right, because that's how we read. But when our eyeballs hit a screen of any kind, they tend to wander. And the reason is because the internet was not designed originally for close, detailed reading. Websites, when you land on a new website, studies show you have about 10 seconds to impress a customer with your website because we don't look at websites for detail. Number 4, increased hand and finger usage increases brain function. So the more you're using and interacting with your hands and gesturing, it increases positively your brain function. Key thought number 5, and this is critical. Let me give you a bit of a neurology background. Your frontal cortex is where you do most of your conscious thinking. That would be this area. This is your temporal lobe where auditory processing happens, especially you musicians. The visual cortex, where we process visual information, is in the occipital, which is back here. There's a part of your brain right here that's tucked between the auditory and visual cortex called the left angular gyrus. It is featured in this neurological medical journal. And what studies have shown that that particular part of your brain processes what's called visual spatial math. visual spatial math. Math related with visual items, spatial 3D. And that visual spatial math is connected to your fingertips, not your eyeballs. That part of your brain that it's connected to your fingertips, not your eyeballs. That's called the left angular gyrus area. So physically tracing and drawing in math diagrams will increase your comprehension because that's the part of your brain that processes the information and then it sends it to your conscious part of your brain that says, oh, I understand this problem now. So what does this look like in my class? When you're working with diagrams in geometry, it is absolutely vital that you physically trace every aspect of the diagram. Every aspect of the diagram. So when you're doing math problems like these, this is my expectation. I'm going to be color coding. Colors are helpful. You don't have to have colors though. So here we have a segment FD. So the minute I read segment FD, my finger is simply tracing from here to here FD. See the little finger? Your finger should physically trace it. The distance F to E is 6. So for distances, I'm going to do a little bracket, and I retrace the number. That tells my brain that that distance is 6. Follow along, please. The distance F to D is 18. We're being asked to find D to E. You have 10 seconds. And of course it's 12 because your brain physically processed 18 is physically longer than 6 and therefore you simply subtract. Down here we need to correct a little typo before we move on. This says it's 11 but F to E is actually 12. So fix that typo. Some of you may have been able to do this without physically interacting. It's fairly simplistic, but as diagrams get more complex, your brain's going to need to kick in that left angular gyrus in order to process the information. So for example, right here, first off, it says that we have segment GD. So physically trace GD. Your finger's on the screen or your finger's on the paper, GD. Just physically trace it a couple times. The distance F to D is 15. Color code this. So we're going to use a bracket because things are going to get overlapping. G to E is 18. You're being asked ultimately to find G all the way to D. Now it's very important. If you just glance at this, some people think it's just 18 plus 15 and you get a number. Believe it or not, I've actually seen this. So that's not what we do. Let's physically process. You ask yourself what you can do. If you don't understand how to do it, you ask yourself what you can do. So we can go like this. It's very easy. And we physically trace. And if that's 15, physically trace this. That's 12. That tells us that's going to be 3. You always ask yourself, what can you do? Let's come over here. We got 18. Let's see what we can do with 18. I'm going to make a bracket. So my brain physically registers that distance is 18. And then this is 12. So we can come over here. And you see that's 18 minus 12, of course. And we get 6. Let's see if we have enough information. So that's 6 plus 12 plus 3. 6 plus 12, of course, is 18. plus 3, and we have GT is 21. Here, number 3, when you're working with angles, I would like you to physically trace. So let's trace the information that we have here. We know from here to here is 115. Now, even though there's a number there, I want you to physically redraw it. See those 2 dots? I like you to sweep between the 2 dots. And we don't know that. Now, the key to this problem is this. See those 2 yellow X's? I like you to sweep a rainbow between them. Sweep a rainbow. Once you swept that rainbow, hopefully in your brain it registered it's half a circle. Therefore, we get 65. Follow along. Here we want to sweep B. Sweep that, and again, even though it's already there for you, I want you to rewrite it. Sweep and rewrite. That helps your brain register. You've actually seen that number. See these 2 dots? I'd like you to connect them. Sweep what you're trying to find. See that X? I'd like you to put your pencil on X and sweep an entire circle. Now your brain just probably registered, oh, that's 360. Therefore, to solve this problem, of course, so you simply add what you have. And you take it away from 360. Please don't use calculators for simple addition and subtraction. Train yourself to do that longhand, please. It's good for the brain. 78 degrees. So notice, I want you to trace every single aspect of the diagram. Taking a look at this one, I'm going to teach you something called thing equations before algebra, and I'd like you to get used to doing this, things before algebra. I'm going to set this up, and then you're going to solve yourself. So what I mean by things, geometry is a math about things, not simply numbers. So in this diagram, this is what a thing equation would look like. A thing equation would look like this angle plus this angle equals that angle. Little angle plus little angle equals big angle. That's called a thing equation. I want you to get in the habit. You're so trained to immediately go for the algebra. I do not want you to see the algebra first. I want you to learn to think in terms of the things, the diagrams, the angles. That's super important. So here, once you have a thing equation, then you're going to do what I call circle, plug, chug, where you circle the aspect and you put it in your thing equation. So now we're down here. Okay, that's a thing equation. That's translating things into algebra. At this point, you're going to pause the video, solve for x, and plug it back in. Welcome back. Let's check your math here. you should have gotten 8x equals 160. Therefore, x is 20. 5 times 20, and this is 101, and this should have been 79. I'm going to reintroduce you to perimeter and area. This is a very simplistic concept, but there's some things I'd like you to always do. Perimeter for a rectangle, I want you to think picket fence. An area for a rectangle, I'd like you to think of grass. So when you're dealing with perimeter, I always want you to physically walk your pencil around the picket fence. Notice the little arrow. The little arrow tells your brain, I've walked around. So whenever you're dealing with perimeter, I want you to physically walk your pencil around the perimeter. Whenever you're dealing with area, I'd like you to take the time and actually shade the area. Physically shade it. Okay, perimeter. We have length and width. Length is longer usually. Perimeter. This is the equation I'd like you to use. As you physically walked it around, it's going to be length plus width plus length plus width. That is the version I'd like you to use. Commonly, you have seen this. I do not want you to use that version because students get lost in the distributive property very often. Also, when you write equations, equations have two sides with an equal sign. If I ask for the equation for perimeter and all you write is this, on a test, I will mark you down. That's not an equation, that's an expression. An equation has two sides with a unequal sign. So you need to write it as perimeter equals length plus width plus length plus width. Area, again, physically shaded. And area equals length times width. Again, if I ask you for the area equation for a rectangle and all you do is write that, I will mark you down. Not a lot, but I will mark it as incorrect. That's not an equation. An equation has two sides with an equal sign. Area equals length times width. It's very critical. All right, students, you're going to take 1 minute and go back through these pages and recite to yourself or a family member the key concepts learned today.